Welcome to Chapter 20, Part 1, Air Pollution. We'll be going from slide 1 through 8 today. Looking at atmospheric composition, note that 78% nitrogen, 20% oxygen, and by now you should have learned that the atmosphere hasn't always been this concentration. It was devoid of oxygen until we had photosynthetic organisms and had a higher carbon dioxide level when there was no oxygen. And obviously photosynthetic organisms played a part in decreasing that carbon dioxide. What we're really concerned about with the composition or the change of composition is that carbon dioxide has increased almost 100%, not quite, probably 75%, from when I started teaching this, and it started out at 0.025% of the atmosphere and is now up to 0.4% of the atmosphere. So we're seeing an increase in carbon dioxide, and we're going to be talking about that in the next two chapters, actually 3. This unit is going to encompass 20, 21, and 10. We're going to go back to urbanization and look at its effect. Okay, looking at atmosphere's ecosystem services, what does it do for us? Well, blocks UV radiation. So blocking UV radiation comes from the ozone in the stratosphere. So the two main atmospheric levels or layers that we're going to be talking about are the troposphere, which is the air you breathe, and the stratosphere, which is the next layer. That's where a lot of the planes fly. And looking also at moderation of climate, and that's due to the normal greenhouse gases, and also its ability to distribute water around the world. Terminology: air pollution, anything that's harmful that has been added to the atmosphere. This can be through natural events or human activities, and there again it has to be in a concentration that is high enough to cause harm. Okay, air pollutants can come from forest fires. Air pollutants can come from volcanoes. Volcanoes spew out a lot of sulfur dioxide, or SOx, and that is a potential for acid rain. Also, forest fires put lots of carbon into the atmosphere, some nitrogen into the atmosphere, and the difference between forest fires and volcanoes and human activity is that the forest fire and the volcano, they're natural. Therefore, they are an event. It is going to affect air quality for a short period of time, but then the air can go ahead and kind of cleanse itself. Where when we have human activities, more than likely this is a continual degradation of the atmosphere. So the atmosphere has no time to heal, and then concentrations build up and do become harmful over a long period of time. When we look at categories, we're looking at primary pollutants and secondary air pollutants. You need to know the difference between these two. Primary is something that directly goes into the atmosphere. Carbon dioxide, carbon monoxide, sulfur dioxide, having problems here, nitrogen oxide, all go in as primary pollutants. Then when they're in the atmosphere, the natural gases of the atmosphere, oxygen, nitrogen, methane can be a primary as well, as a natural part of the atmosphere. Those primary pollutants bond with the gases of the atmosphere that are naturally there. Oh, and water vapor also is a contributor to a secondary pollutant. They bond with those and then create a secondary pollutant that is harmful as well as the primary pollutant. So we're going to look at that more in part 2. Okay, this is just a graphic showing you primary pollutants and secondary pollutants, and basically what we're looking at, these are all primary pollutants right here. Or, well, no, they're not. Ozone is a secondary pollutant. Hydrocarbons, carbon dioxides, nitrogen oxides, particulate matter. Okay. As all of those from different sources move into the atmosphere, they bond again, many of them with oxygen and many of them with water. And then they become acids. You have nitric acid being made. You have sulfuric acid being made. And then we also get some ozone being made. All of those part of what we call smog, and in high levels are health hazards to humans. You can look through this on your own, just a table telling you what it is, doesn't really, and giving you the composition, doesn't really tell you the impact. Particulate matter, anything that is a particle, it can be solid, liquid, soil particles. We've talked about the Dust Bowl. Soot or ash from volcanoes or forest fires or just us burning things. Lead used to come from cars burning oil, used to come from coal burning. Asbestos, we haven't talked about yet. Asbestos is used in insulation and fire retardant materials, and it is a fiber that is almost like a piece of glass, and it gets into the lungs. It's very, very fine particulate matter, and it can get into the lungs and cause lesions in the lungs. And anytime that your lungs bleed, or the capillaries in your lungs, the tissue matter is compromised at all, when it heals, it normally heals as scar tissue. Therefore, you lose the ability to exchange oxygen and carbon dioxide at that point. So asbestos is usually from man-made substance that we put it into the atmosphere anyway. Sea salt and sulfuric acid drops. We've talked about how salinity level, if it would get deposited, it can hurt ecosystems, and we'll talk about acid rain later on. SOx and NOx, again, this we discussed when we were talking about coal burning, power plants, and these nitrogen oxide is considered a greenhouse gas. Sulfur oxide is not. Know the difference there. You can get tripped up on that. Sulfur oxides in high concentrations, like from volcanoes, because volcanoes spew sulfur. Sulfur actually acts as a retardant to heat. So it decreases the localized temperature. So it is not a greenhouse gas. Carbon monoxide and carbon dioxide. Carbon monoxide is what comes out of cars. It is a clear, odorless gas, and it will kill you if you breathe it. So will carbon dioxide. But they are both considered greenhouse gases. Anything that has hydrogen and carbon in it is considered a hydrocarbon, and that's normally what you're getting when you burn any kind of gas or any kind of oil or petroleum product, is you're going to get a hydrocarbon. And the most famous, I guess I should say, is methane, and that's CH4. Methane, pound for pound, or volume to volume, holds more heat than carbon dioxide. So it is much more intense in its heat holding capacity, but there is more carbon dioxide in the atmosphere than there is methane. So carbon dioxide levels are really what we gauge. Methane comes from natural processes as well as from us burning fossil fuels. It is microbial action creates methane, as we learned about. That's part of the cows, what goes on in the cow's belly. If you remember looking at Food Inc. and the guy sticking his hand in the cow's stomach. Also, just any decay process, these microbes will put off carbon, or put off, methane. And that's the end of part 1. We'll start part 2 with the ozone layer.